Good morning, my lovely kiddos and my future mathematicians. Today we're going to talk about 7.3b, and we are going to prove shapes are parallelograms using the points of these shapes and our 5 super cool rules. We have 3 different ways that we can prove a shape is a parallelogram using its points. So let's go ahead and get into it. We are going to have 4 points. Point A is at -3, 0. Point B is at -1, 5. Point C is at 5, 4. And point D is at 3, -1. So we're going to go ahead and plot these on a coordinate plane, and we're just going to go ahead and draw that, and that looks like a big old plus sign. Okay, and then we're going to go ahead and plot these. So A is at -3, 0. So that means, remember that all of our points are X, then Y. Our horizontal axis is our X, and our vertical axis is our Y. So starting at our origin, or 0, 0, we are going to move 3 units in the negative direction left, 2, 3, and then we have no direction for Y because we have a 0, so we are going to put that point A right on the x-axis. Point B is at -1, 5, so we move left 1 on the x-axis and then up 5 in the positive y-axis. There's our point B. Point C is at +5, +4, so we're going to move from the origin right 5 units, 3, 4, 5. So over 5, up 4. I put this B too low. Here we go. That's for our point C. And then D is +3, -1. So over to the right 3, and then down 1. And that is our point D. We're going to connect all of these points and make a shape that could be a parallelogram. Okay, the first way that we can prove that this shape is a parallelogram using only its points is by using the distance formula. So let me write down the distance formula for us. The distance formula is D for distance is equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. That is all under our square root. So what we're going to do is we're going to find the distance between A and B, B and C, C and D, and A and D. Okay, so we're going to find the distance of all 4 sides to see if our opposite sides have the same distance and they are congruent. Okay, let's start with side AB. Okay, so again, point A is -3, 0, and point B is -1, 5. So the first thing I'm going to do is I'm going to pick my favorite point, making that my x1, y1, and then our other point would be our x2, y2. It does not matter which point you pick to be your favorite, you will get the same answer either way. Okay, so we're just going to take these x1, y1 numbers and plug them into our distance formula and then get an answer. So we have D for distance is equal to the square root of x1 is -3 minus our x2, which is a -1 squared, plus our y1 is 0 minus our y2, which is 5 squared. Okay, so we're going to solve the things inside the parentheses before we square them. So I'm just copying everything down. D equals the square root of -3 minus a -1. Remember, when we subtract a negative, we're really adding a positive. So -3 plus 1 will give us -2 squared. And then 0 minus 5 is going to give us a -5 squared. Okay, then we will go ahead and square these. So -2 times -2, or -2 squared, will give us a +4. plus -5 times -5 is going to give us a positive 25. Now we're going to go ahead and add these two together. 4 plus 25 gives us 29. And then we will take our calculators and we simply have to, I hit second and then our square root function button and then plug in 29. And it gives me 5.38. So I'm going to do a little approximate sign. So 5.385. I'm just going to go out 3 decimals. Okay, so we found the length between A and B. So now let's go ahead and do B and C. All right, so B to C, or our top section of the shape you can no longer see. Point B is at -1, +5, and point C is at 5, 4. So once again, we're going to pick our favorite point. I'm going to pick B to be my favorite point, my x1, y1, and C to be my x2, y2. Again, it does not matter what you pick. And then we're just going to plug in our numbers. So we have D is equal to the square root of our x1, which is -1, minus our x2, which is 5 squared, plus our y1, which is +5, minus our y2, which is a +4 squared. Okay, -1 minus 5, that is going to push us further into the negatives. It's going to give us a -6 squared. And then 5 minus 4 is 1 squared. So now we square these or multiply them by themselves. -6 times -6 gives us a positive 36. And then 1 times 1 just gives us 1. Okay, so using our calculator here, we plug in, we get the square root of 37. So we hit our square root function here and then type in 37. And that gives us approximately 6.083. Again, just rounding out 3 places after the decimal. Okay, we did BC. Let's go ahead and do CD. Point C is at 5, 4, and point D is at 3, -1. Okay, once again, we're going to go ahead and pick our favorite point. I'm going to pick C to be my favorite point, my x1, y1, and D to be my x2, y2, or my second favorite point. Okay, so now we are just going to go ahead and plug these points into the distance formula. So D is equal to the square root of our x1, which is 5, minus our x2, which is 3 squared, plus our y1, which is 4, minus our y2, which is -1 squared. Okay, now we just combine the things inside the parentheses. So 5 minus 3 gives us 2 squared. And 4 minus a negative, remember minus a negative is really adding a positive. So 4 plus 1 gives us 5 squared. So D is equal to 2 times 2, or 2 squared gives us 4. And 5 squared gives us 25. 4 plus 25 gives us 29, the square root of 29. And then to get our decimal approximation, we will take our calculators and we will type in the square root. Ooh, helps if it's on. Square root of 29. And again, we're just rounding out 3 decimals. So that is approximately 5.385. And then the last segment we're going to find the distance of is from A to D. So A is at -3, 0, and D is at 3, -1. Okay, I'm going to pick one of these to be my x1, y1. Again, it does not matter. And the second to be my x2, y2. And then we're going to plug these into the distance formula. So we have d is equal to the square root of our x1, which is -3, minus our x2, which is a +3 squared, plus our y1, which is 0, minus our y2, which is a -1 squared. Okay? So -3 minus 3, that's just going to push us further into the negatives and give us a -6 squared. And then 0 minus a -1. Remember, minus a negative is really adding a positive. So 0 plus 1 just gives us 1 squared. Okay, then we go ahead and square these. 6 squared, or 6 times 6, -6 times -6, my apologies, is a +36. And then 1 times 1, or 1 squared, just gives us 1. When we add those together, we get that the distance is equal to the square root of 37. And to get our decimal approximation, we're going to bring out our calculators, hit our square root function, 37, and that gives us approximately 6.083. Again, just rounding out 3 places. Okay, so if we write all of our segment lengths onto our drawing here, so let's go ahead and do that. A to D is 6.83, so A to D is 6.83083, my apologies. And then if we look at our work here, we can see that A to B is 5.385, so 5.385. B to C is 6.0683. Gosh, if I could talk. So 6.083. And then finally, C to D was 5.385. 5.385. And now with all of this written in, we can see that the opposite sides, or the sides that do not touch, they are congruent. Those segment lengths are equal. They are the same. They are congruent. So this is a parallelogram by finding the distance between all of our segments. All right, using the same diagram, this time instead of using our distance formula to find all of the distances to see if our opposite sides are congruent, this time we are going to be using the slope formula to see if opposite sides are parallel, which is another one of our super cool rules. So our slope formula is m for slope is equal to y2 minus y1 divided by x2 minus x1. Okay, so again, we're just going to go around the figure and find the slope for each line. First AB, then BC, then CD, then AD. Okay, so let's find AB first. Point A is -30, and point B is -15 once again. Okay, so we'll just go ahead and plug that into our formula. Well, first we have to pick our favorite point, our x1, y1, and our x2, y2. Again, it does not matter. You'll get the same answer either way. Now we just plug into the formula. So we have m for slope is equal to our y2, which is 5, minus our y1, which is 0, divided by our x2, which is -1, minus our x1, which is a -3. Okay, starting with our numerator, or our top part here, 5 minus 0 gives us 5. A -1 minus a -3, remember minus a negative is really adding a positive. So -1 plus 3 will give us a +2. We cannot reduce this fraction of 5/2, so we're just going to leave it the way it is. Okay, next we want to check B to C. Point B is at -1, 5, and point C is at 5, 4. Again, pick your favorite point, your x1, y1, and your second favorite point, your x2, y2, and then go ahead and plug it into our formula here. So once again, m for slope is equal to our y2, which is 4, minus our y1, which is 5, over our x2, which is 5, minus our x1, which is a -1. Okay? 4 minus 5 is going to give us a -1. And 5 minus a -1 or plus a +1 gives us 6. Again, this is a fraction we can't reduce, so we're just going to leave it the way it is. Moving on to CD. Point C is at 5, 4, and point D is at 3, -1. Go ahead and pick your favorite point, your x1, y1, and your second favorite point, your x2, y2, and then plug into our formula. So we have our our y2, which is -1, minus our y1, which is 4. And then we have our x2, which is 3, minus our x1, which is 5. Okay, so we have -1 minus 4, which will give us a -5. And then 3 minus 5 will give us a -2. Whenever we have two negatives stacked on top of each other, we can go ahead and just take those negatives away, or you could think of taking out a negative out both of those. So we get a +5 over +2. And then our last segment here, we have A to D. Point A is at -3, 0, and point D is at 3, -1. So once again, we just pick our favorite point, our x1, y1, and our x2, y2. Okay, plugging that into the formula. Ooh, I forgot my m on this last one. We have m for slope is equal to our y2, which is -1, minus our y1, which is 0, over our x2, which is 3, minus our x1, which is -3. -1 minus 0 is still -1. And 3 minus a negative, or add a +3, so 3 plus 3 gives us 6. So if we go ahead and write in the slopes into our diagram here, we found that AB, this first one here, was 5/2. We found that BC is -1/6. We found that CD is also 5/2, and we just found that AD is also -1/6. Since our opposite sides have the same slope, that shows that our opposite sides are parallel, which is one of our super cool rules. So the shape, again, is proved to be a parallelogram. And then our last way to prove that a shape is a parallelogram is to use our midpoint to show that the diagonals bisect. Now, the diagonals bisect or cut each other in half. So if they both cut each other in half, then they should have the same midpoint or the same center, okay? So I'm going to draw in our diagonals here, just connecting the 2 points that are not already connected. So we have one A to C, and we have one B to D, okay? So our midpoint formula, we're trying to find this point here, and they should match for both our diagonals. So we're going to calculate the midpoint on A to C and B to D. So our midpoint formula is capital M for midpoint, slope is a lowercase m, is equal to our first x plus our second x divided by 2, and then our first y plus our second y divided by 2. Okay, so first we're taking between A and C. First diagonal, point A is at -3, 0, and C is at 5, 4. Okay, again, we're going to pick our favorite point, or x1, y1, and our second favorite point at x2, y2, and then plug it into our formula here. So we have capital M for midpoint is equal to our x1 is -3 plus our x2 is 5 divided by 2. And then our y1, my apologies, is 0 plus our y2 is 4 divided by 2. So -3 plus 5, that is going to give us a positive 2 over 2. And then 0 plus 4 is going to give us a 4 divided by 2. 2 divided by 2 gives us 1, and 4 divided by 2 gives us 2. So that 1, 2. Now we're going to check our second diagonal between B and D. So point B is at -1, 5, and D is at 3, -1. Again, we're just going to pick our favorite point. Pick 1 to be our x1, y1, and 1 to be our x2, y2. It does not matter. And then we plug it into our formula. So once again, capital M for midpoint is equal to our x1, which is -1, plus our x2, which is 3 divided by 2. And then our y1, which is 5, plus our y2 is -1 divided by 2. -1 plus 3 gives us a positive 2 over 2. And then 5 plus a -1, or 5 minus 1, gives us 4 over 2. 2 divided by 2 again gives us 1, and 4 divided by 2 again gives us 2. So since our two midpoints match, we did find this point. It's not exactly, since this is hand-drawn, the point's actually right around here, but it's close. So since our two midpoints do match, then our diagonals do bisect. That matches one of our super cool rules. So we have proved that this shape is a parallelogram 3 times with the distance formula, with our midpoint formula, and using our slope.